I'm going to do my best to turn the microphone on. Let's start that again. Welcome to Quadratic Equations. I'm going to be explaining quadratic equations, something that causes a lot of confusion. If you are year 5 and 6, what are you still doing here? But thank you for joining me. But if you're here and you're a higher tier GCSE or even A-level student who's always had a bit of a problem with that area, hopefully I'm going to go through it, explain what's going on, and you will, by the end of this video, have a better understanding or even a perfect understanding of what you're supposed to be doing. I promise you, by the end of this week, at least one of these videos will be done without me being on mute for the start of the video. So, there's a big promise. I'm getting better with the technology, but still messing up when it comes to making myself being able to be heard. So, let's start with me here. We are going to be working our way through some quadratic equations. Now, the first sorts of quadratic equations we're going to be looking at have a very straightforward format to them. This may well be very simple revision for you, but it sets us up for where we're going. So these are the ones where it's like x squared plus 7x plus 10. And for the moment, we're not going to have anything equals. We will come back to, before the end of the lesson, we will talk about when they're equals something, but for now, we're going to leave it just like this. What we're looking for here is a pair of double brackets, and we know it's a pair of double brackets because it's an x squared, an x, and a number. This is also true if it's just an x squared and a negative number, such as 121, but it's not true if it's an x squared and an x. That would go into a single bracket. What I do when we're doing this is I look for, first of all, the clue is the word factorising. It's right there in the name of the thing. So factorising means I don't expect anyone just to try and cut corners and not write down the factors of 10. So once I've got the factors of 10, it's straightforward to see that 2 and 5 make 7, and we have x plus 2, x plus 5. The other way around is absolutely fine as well. They are both correct. So what we've got here is factorising straightforwardly when there's no x squareds. No amount of x squareds. It's just 1. We can go to the most difficult that gets, which is here, when we have x squared plus minus 6x minus, let's say, 40. So I've got a bit more to do. Again, it's factorising. Don't cut corners. Write negative 40, not 40. It's negative 40, so we're going to write 1 times negative 40, 2 times negative 20, 4 times negative 10, and 5 times negative 8. The others are all true as well, but for now this is enough because, thank you Izzy, we can now see one of these pairs makes minus 6. If it made plus 6 and we wanted minus 6, we'd just put the negatives the other way around. So therefore I know I need x plus 4, x minus 10. Now this is the bit where I'm going to talk about, for the first time, what if it said it was equal to 0? If it says it's equal to 0, then you know that this bracket times by this bracket equals 0. That bracket, so the x plus 2 times by x plus 5 makes 0. So one of those brackets has to be 0. The only way you can multiply two numbers together and get 0 is if one of them's 0. So which means the only way we can make this bracket 0 is if x is minus 2. Because minus 2 add 2 is 0. The only way we can make this one 0 is if x is minus 5. And when they're single numbers like this, until later, it will suffice for you just to go, it's the opposite of what's in the bracket. However, when we get onto the harder ones, we will see That's not the case. Now, if you are top set and this is all too straightforward, I understand, but I have to start from somewhere that everyone can make sure that they're following through procedurally. If there's anything here you have not understood, please make sure you stop, rewind and watch again, either after the video or now, just to make sure that you're familiar with what is going on. If we're all together, then I will proceed on to what happens when a spanner gets put in the works. And I have 3x squared minus 13x minus 10. There are two methods I'm going to show you here. The method I used when I was at school, and what I use now because I think it's better and more resilient. When I was at school, I did a method where I knew it was going to be double brackets. I looked at the 3 and went, well, that has to be 3x and x. And then I looked at the numbers and kind of just worked out my numbers to make minus 13 just by listing the possible numbers. 1, 2, 5 and 10, minus 10, minus 5, minus 2 and 1. And then I do multiplying like the opposites. 3x times minus 10 is minus 30 plus 1 is not going to give me minus 13. So that's going to cross off that one. 2 times x and minus 15 is the right one. So it would be plus 2 and minus 5. Because minus 5 times 3 is minus 15x and plus 2 times x is plus 2x, giving us minus 13. It's reasonable, but for reasons I'm going to show you in the second example we do, it's too long and too, for me, it's too much working out things in my head. I wanted a method that was resilient and would always get me straight away there without having to do too much thinking. And so I was delighted when I came across this method of doing this. And what that is to take the first number and the last number, times them together, and find the factors. Remember, this is factorising of minus 30. Minus 1 times 30, minus 2 times 15, minus 3 times 10, and minus 5 times 6. Remember, I don't bother finding the other pairs because if we get plus 13, we know we have to switch the numbers around. And in fact, this happens here. Minus 2 added to plus 15 is plus 13. But we want minus 13. So we have to switch this round. This must need to be 2 and minus 15. Because we want the other one. But we don't put these in the brackets. We rewrite the whole thing out, 3x squared, but now we split that middle bit into 2x minus 15x minus 10. All I have done is taken that middle bit and split it into a 2 and a minus 15. We are then going to be able to put a dotted line down the middle and factorise each individual bit. We take x out there, giving us 3x plus 2, and we take minus 5, giving us 3x plus 2. In fact, these brackets must be the same. They have to be the same. So you can even write them in to help you find what the other number is. You cannot, if you've got two different ones, you've made a mistake. This then tells us that the factorised version must be excuse me, 3x plus 2 and x minus 5. You can have them the other way around, but you'll notice this is exactly the same as the answer I got up there. Now you might think, but the first method seemed quicker. For this one, maybe it was. But what I'm about to show you is why I think it's more resilient to use this method every time. If there's anything about this method that you're not clear on, please do put a question in the comments, do put a question in the chat, and I will try and get back to you as soon as I get the opportunity to answer and explain why I did something or how I got something. So the next question I'm about to go through with you, the reason it's a bit different is because it's 4x squared plus 8x minus 21. So when I try and do this method I was going to do before, where I just put the brackets out, it could be 4x and x, but it could also be 2x and 2x. So because of that, I'd have to try so many different combinations. You can imagine, once this number gets bigger, there's even more combinations. If it was 36, you'd have 1 and 36, 2 and 18, 3 and 12, 4 and 9, 6 and 6. There's lots of different combinations it can be. Whereas, if we do our simpler 4 lots of minus 1, minus 21, is minus 84. List our factors. 1 times minus 84, 2 times minus 42, 3 times negative 2 and 24, 28. And 4 times negative 21. And 5, 6 times negative 14. And 7 times negative 12. And 8 doesn't, 9 doesn't. 10 doesn't, 11 doesn't. We're then looking for a pair that makes the 8. I can spot a pair that makes negative 8, which tells me, fine, I need it the other way round. So this is going to split into negative 6x and plus 14x. It's the other way round because we want plus 8x. Keep the 21, keep the 4x squared, draw a dotted line down the middle, and we've got 2 separate factorisings to do. X brackets x minus, but I'm going to take 2 out because it's in 4 and 6. So it's 2x times 2x and 2x times minus 3. Remember, that tells us instantly it must be 2x minus 3. No ifs, no buts, no coconuts. The next thing we're going to have to do is multiply by plus 7. So we've therefore got 2 brackets, 2x minus 3 and 2x plus 7, giving us this overall answer. Now, I did mention earlier about making them equal 0. We've been doing them as expressions so far. So the logical thing now is to go back up a little bit and go, well, what if it was equal to 0? And I was doing that with purple before, so let's try and keep it familiar. If it says it's equal to 0, then our answers, we do everything the same. So the only thing that changes is this bit here, where we can then say that means 3x equals minus 2 and x equals minus 2 divide by 3, or x equals plus 5. So this one was the same as before, where it's just the opposite sign, but this one was 3x is equal to minus 2, the opposite sign still, but 3x now, so we have to divide by 3. Likewise, the one we've just done, we can come down, if the question said it equaled 0, everything's the same except here is equal to 0, so we can then say 2x equals plus 3, it's the opposite, x equals 3 over 2, or 2x equals negative 7, x equals negative 7 over 2. Remember, the sign has changed. Now, one thing they like to do when I say they, the mysterious exam board corporations, they like to do is they like to put questions in where they're not quite as balanced as you would like. I'll show you one of what I'm talking about. So this is going to have a caution, and it's going to be slightly radioactive about it. So what am I talking about? I'm talking about this question here. 9x squared minus 23x plus 6 equals minus x minus 6. And the question would say solve, probably by factorising. What this means is we need it to equal 0 before we start. We cannot do anything until this has come and joined the other side, and so has this. Meaning I am going to do this as, I'm going to put the x squared in here, and I'm going to do this as 10x squared, because I've added this x squared on, minus 23x stays the same, and plus 12 because we've added 6 on. Now I just want to point out, by the way, for anyone who has watched some of my videos, the worksheets that are in the description below is designed to help people, but I've had to steal and borrow lots of worksheets and things. I've got a lot of things from the internet. I've got a lot of things that people have made. I make no bones about the fact that I am very, very grateful to all the people that have done things. I'm not trying to get a personal benefit out of that. I'm just reusing worksheets and things to try and give everyone the learning at home. I would be making my own worksheets if I was doing this as a full-time job, but because I'm doing this for the live streaming during the day and because we're all stuck at home in this weird thing, I just want to give some credit to all the people who have put things on the TES website and things that I've been able to borrow and use. So let's have a look at this question. This is now equal to 0. More on that later. First off, we're going to take our 10 and our 12. 10 times 12 is 120. So we're going to list our factors of 120, but it's a minus. So these must both be minuses. Minus 1 times minus 120, minus 2 times minus 60. Minus 3, there's going to be a lot of these. So if I spot which one it is, I will stop at the one that is the right one. Minus 4 times minus 30, minus 5 times minus 24. Yeah. Minus 6 times minus 20, minus 8 times minus 15. Bada! Stop! That makes minus 23. Therefore, if that's minus 23, we can split this into 10x squared minus 8x minus 15x plus 12 equals 0. We're going to cut it down the middle. This has got 2x going into the 10. 10 and 8 both divide by 2, and the x is in each. So we've got 5x minus 4, which tells us it must be 5. Again, no discussion here. Has to be 5x minus 4, which tells us that this is minus 3. So we've got 2x minus 3 from the outside and 5x minus 4. This equals 0, so we're going to go back to our purple, which we use for solving. We've got 2x equals minus 3, plus 3, so x equals 3 over 2, or 5x equals 4, so x equals 4 over 5. Now, one thing I expect some students, not everyone, but some students to be confused about is why we've got this or in our solutions. How can we have two solutions which have an or about them? Completely understand that. This is all to do with the graph of the equation. If I make this a bit clearer, the equation we're talking about here, I'm going to do it two ways. I want to do it first of all the straightforward way. Once we simplify it, we had 10x squared minus 23x plus 12, and that's y equals. If I now highlight this and maths it and then draw the graph of it, hopefully if I zoom in a bit we can see this graph here, 10x squared minus 12x plus 23x plus 12 is equal to, there's two places it goes below the line. Those two places are here and here. and it just so happens they are at 4/5 and they are at 3/2 or 1.5. 1.5 is here and 4/5 is here. So the solutions are the two places this line crosses the graph. If there are multiple ways, then if there's only one way, it means it touches the graph. And if there's none, it's got no solution. If the graph is above the line, there would be no answers. It just wouldn't work. The factorising would break. Actually, what I was also going to show you is what happens if we've got the situation like we had before. X squared minus 3x plus 23x plus 6. Now I have very little faith that this is going to work, but we shall see. I might need to redo it. Yeah, it doesn't really like it, so I will redo it. It's not a problem. Oh, there's my vector stuff for later. So we've got y equals 9x squared minus 23x plus 6. This is the first equation. And the reason I'm showing it is because I want people to understand how this is related to this. What this is saying is, when there was this equation here, this was the first equation. If we now draw minus x squared minus 6, minus x squared minus 6 will be something like this. And those 2 points should be these 2 points here, because they are the 2 points where this line meets this line, whereas this is the point where it meets the graph. But notice they're the same values of 1.5 and 0.8. They're exactly the same values. It's just one is the two lines meeting each other, and one is one line that we combined meeting the value of 0, meeting the line. That, in 25 minutes, covers everything there is to cover about factorising. Now, the best thing I recommend you do is the worksheet that's in the description below the video. Click show more and you'll extend the description. You can find the link, click on the link, try those questions. I'm always happy to answer anything. Put comments if you did find this useful and you did learn something. Even if you're watching it back in future times, please do click like, do share it, do feel free to subscribe to the channel for more, whatever subscribing is, for more higher tier GCSE things. And hope being locked down for the next 2 days is not too bad, and I will speak to higher tier students again on Wednesday. You are all wonderful people.